And we had stopped the last time by looking at how the monopolists can set a price that will make as much money as possible. And it makes sense that the monopolists will take into account that the cost of producing another unit, the price has to cover that cost, and also how sensitive the consumer is to prices. The more sensitive that the consumer is toward pricing, the lower the price, of course, that the monopolist should set. So that it is selling computers, for example, even to consumers who are willing to pay only a low price for them. So basically, this is a formula for selling as many products as is possible, given the preferences of buyers. So if you're wondering where the formula comes from for extra credit, you can derive it yourself.
Professor, excuse me, could you show the extra credit task again, please?
Yes, it's also on the Moodle page, or will be after I post it.
Oh, thank you, Professor. Then there is no need to show it. I will find it on Moodle later. Thank you.
So there it is.
Thank you, Professor.
Okay. I'll make a note to be sure to check that Moodle has that slideshow.
Okay.
So in this example, but the monopolist wants to maximize profits. And its profits, as always, are equal to revenues, total revenues minus total costs. Total costs depend on how many computers, for example, that you're producing. But computers are properly produced. And revenues depend on the price of each computer times the number of computers that you are producing. The price itself for the monopolist depends on quantity. So if you want to sell more computers, you will have to lower your price. The extent to which you must lower the price depends on how much you're already producing. So there are revenues. And they will usually assume that the inverse demand function is linear, although not really necessary to this particular problem. Okay. So profits or revenues minus costs. There are total revenues and then there are total costs. So pick the quantity level Q that will maximize this expression. So if you're applying calculus, then take the derivative of profits with respect to Q equal to 0. So you remember that first order condition. However, the expression may look a bit convoluted in that we have a product of price and quantity in the first term. So remember your product rule from calculus. That this, let's just say, G is a product of two functions of x, f and g. Then the derivative treats in turn the other product, the other function as a constant, and then you will differentiate the remaining product. So in this case, first, we treat f as a constant, and then differentiate g. Next, differentiate f and hold constant g. So this example, suppose that the f function is equal to 2x, and the g function is equal to 3x. Then can you take a moment to apply the product rule to come up with the derivative of g with respect to x? So just think about that for a couple of minutes for 1 point of extra credit, and then we will reconvene to see what your answer is. A couple of minutes. Okay, so what did you find out using the product rule? Well, let's see. Let's first take f as a constant and then differentiate g. And then next, differentiate f and treat as a constant the g of x. So let's see what we have. F of x in the example is just 2x. And then we will differentiate g with respect to x. And what is that? Just 3. And then next, we will differentiate f and take a times function g of x. Differentiating f with respect to x gives us 2. And g of x is 3x. So it's a very easy rule to apply. In this case, we have 6x plus 6x with 12x all told. And then we can check our results. G in this case is the product of f and g, or 2x times 3x equal to 6x squared. So to check the results, you could differentiate this expression to z, 6x squared, with respect to x, by using the power rule. And therefore, the derivative is 12x, exactly the same result as we had arrived at by using the product rule. So no problem there, I hope. Okay. So now we can go back to our problem of maximizing profits for the monopolist. Now to know how to differentiate the first term, which is a product. And then set the derivative with respect to q equal to 0. So let's see what we have. For the product rule, you can treat the first function in the term p of q as a constant. And then differentiate with respect to q, which just gives us 1. Next, differentiate with respect to t, the price. And then treat q as the constant. And then finally, differentiate total cost with respect to, and we're done. Since this is the first order condition, people set it equal to zero. So we have in this expression twice plus the slope of the indirect demand function. Minus marginal cost, all equal to zero. So now, to finish the problem for extra credit, solve for the price, and then manipulate the expression to include the elasticity. So you remember that the elasticity is the relative change in quantity in response to a relative change in the price. And if you take a look at our expression, we already have part of the elasticity in the second term, although it is inverted. So I will leave it to you by Friday to determine how to finish the problem. All that you really need to do is to find some way of expressing the second term as an elasticity. Last time, we found that if the firm is competitive, then our price function instructs us to set a price equal to marginal cost. And we also worked through this example. However, here is a more challenging puzzle. Our formula for the monopoly price implies that the price elasticity is not less than 1 in magnitude. So there is the expression. Suppose, for example, that the elasticity is very close to zero. a very low sensitivity to price. But in that case, the denominator for the price function is negative. And so we will derive a negative price in that case. This does not make sense. So we will impose the condition that the elasticity in magnitude is not less than 1. Because if it is less than 1, we will have a negative denominator. So let's think for a moment about why that assumption for the monopolist seems to be reasonable. Let's draw the inverse demand function for the monopolist. Maybe in terms of superior ice cream. So Oxo is the only person in Almaty who sells superior ice cream. So he has nothing on that market. And here's the price. And then finally, the demand function. So you remember that when we talk about elasticities, we found that this was the relative change in Q as compared to the relative change in price. And you remember that we can rewrite this expression as the derivative of frequency with respect to price. So it's the ratio of price to quantity. So on the low part of the inverse demand function, this area right here, we have low values for price and high values for Q. So for example, at this point versus 0 and 2 is large. So on the low part of the function, 3 divided by 2 is very small. And therefore the elasticity is small as well. On the other hand, on the high part of the function, we have high values for price and low values for quantity. So the elasticity up here has a large value, larger than 1 in magnitude. Okay, so in this region, the elasticity exceeds 1 in magnitude. And in this region down here, the elasticity is less than 1. Okay, so that's all we need to know to determine why it is reasonable to think that the monopolist will not have an elasticity less than 1 in magnitude. So consider a point like A. At A, the elasticity is small. And therefore, as we increase the price, consumers will not cut back on purchases from OXXO very much. Revenues will rise. So, for example, if OXXO increases its price from 200 to 300 KA, people increase revenues. From point A up to point B. Or right there. So in this region, Oxford is increasing his revenues, but also note that he is decreasing total costs because he is producing less ice cream at point B than at point A. So at point A, he is selling ice cream to 10 buyers per day. And at point B, he is serving only 8 buyers. So as also raises the price from 200 to 300 tenge, revenues are rising because of the lack of sensitivity to the price increase. And costs are falling because our film is producing less ice cream than before. So what is happening to profit in the story? Profit must rise. In other words, on the low part of the inverse demand function, our flow can always increases profits by raising the price. So no point on the low part of that function can maximize price. It follows then that the monopolists let us go. Will increase the price until he is in the price sensitive zone of the inverse demand function. And in that zone, the price elasticity is greater than 1, or at least 1 in magnitude. This is a point elasticity. So in short, also will never place ice cream at a point where consumers are not sensitive to the price increases. It pays them to raise its price until consumers begin to object. And then people stabilize the price. First is about the intuition. The monopolist to just make sure that he continues to raise the price as long as consumers don't mind. It comes to that. Let's make that exercise due Thursday, due tomorrow. Okay, so here's a puzzle for you. Then the next 3 minutes. Robazan owns a cafe that serves blue melted coffee. This is a very delicious brand. As far as I know, I don't think it sells in the market, but it should. And his interest in that function has useful form of vineyard. And finally, his marginal cost for a cup of coffee is 10 pennies. Can you take a moment now to calculate the output price and profits for Ramazan? 3 minutes, and then we will come back together to solve the problem. Good. Well, let's see how you did. As you remember, we maximize profits for the monopolists by producing at the point the marginal revenue equals marginal cost. We already have marginal cost, but what is marginal revenue in this case?
Marginal revenue is 50 minus 0.004 Q, because it is twice steeper than marginal cost curve.
Yes, good. Yeah, exactly. Good. So let's equate marginal revenue and marginal cost. And then solve for Q as nobody says. So let's add the quantity term to both sides. And then subtract 10. Now notice that 0.004 is the same as 4 in 1,000. So let's multiply both sides by 1,000. Or 4Q is equal to 40,000. So what is Q in this case? Not a trick question. 10,000. Lumber is selling a lot of coffee. So what is price in this case? Using the inverse demand function.
It is 30.
Good. So let's check that answer. We could write the expression in scientific notation. So 0.002 is the same as 2 to the power of 10 minus 3. And then 10,000 is just 10 to the power of 4. So as Levi says, the problem is simple to solve. 10 to the power of 4 10 to the power of minus 3 is just 10. So the price of 140 is 30 tenge. So what are profits in this case? Help me find profits.
It is the same as the revenue.
Say again.
Because there is, it is the same as the revenue because there is no marginal cost. It will be 10,000 multiplied by 30, so it will be $300,000. The profit.
Yeah, but we've done so many problems with
Oh,
the
sorry.
marginal cost. It's all right. So we have a constant marginal cost in this problem.
And we
So
can
that means that marginal cost is equal to average cost. Every cup of coffee costs 10 tenge, and therefore a typical cup of coffee is also costing 10 tenge. Okay, so our revenues in this case, 2 times Q is 2 times 10,000. And then total costs are the same as average cost times over total you're selling or Q. And average cost here is 10. So our profit or revenues minus cost or PQ minus 10 times Q. But the price is 30 peggy. So our profits are 30Q minus 10Q or 50Q. But we've already found that Q is 10,000 right here. So our profits are 30 times 10,000 or 200,000. So you're right, was not very far off because the cost is very low in this case.
Excuse me, could you repeat, please?
Oh, I just observed that your estimate of profits initially was pretty close to the actual answer because costs are very low. They're almost zero, not quite, but almost.
Oh, I see. Thank you, Professor. I understand now.
Profits are high because cost is low. Questions about that problem? So for extra credit overnight. What is consumer surplus in this example?